Hello everyone, welcome to my channel Chemistry by ANR, the part 2 of electrochemistry. We are going to deal with galvanic cell. It is also known as voltaic cell. It's an electrochemical cell. Now here the redox reaction is carried out in an indirect manner. That means we have two different chambers and the reduction and oxidation processes take place in two different containers, two different chambers. Now left hand side, this is your left hand side chamber. So in the left hand side chamber oxidation takes place and in the right hand side chamber reduction takes place. In the left hand side chamber we have a zinc electrode dipped in zinc sulfate solution, and in the right hand side we have copper electrode dipped in copper sulfate solution. Both I have taken, both is 1 molar, so I have written 1 molar for that reason. Now here it is the two chambers are connected by a U-shaped glass tube which is known as a salt bridge. Now I have written K plus Cl minus because I have assumed that I am using KCl. Now salt bridge means it should contain a concentrated solution of an inert electrolyte, and that inert electrolyte can be KCl, can be KNO3, can also be K2SO4. Actually, it is a compound whose cation and anion mobility is almost equivalent. So the ionic mobility should be same. That type of compound is being taken. Now when you connect it, what happens over here is the zinc electrode loses electron due to oxidation. That means it undergoes oxidation. It loses electron and it forms Zn2 plus Aq. So more and more Zn2 plus comes to the solution, and with time there is accumulation of Zn2 plus near the electrode. Now on the right hand side what happens, and let me add on one more thing, that the loss of electron, the release of electron in the left hand side chamber near the electrode results in the formation of the negative terminal, and hence this is the anode. This is not the same as the electrolytic cell where the current is passed in order to carry out the reaction. Here the zinc end is the anode end, and due to the I'll say release of the electron, the zinc end attains the anode or the negative terminal. Now the right hand side copper end, it takes electron, it gains electron, and hence there occurs reduction. When I have written OHC, it means oxidation half cell reaction, and I have written RHC, it means reduction half cell reaction, and here gain of electron takes place. So Cu2 plus takes 2 electron, and taking the electron results in the positive terminal and it forms the cathode. Since electrons are released from the cathode to neutralize the Cu2 plus Aq ion, it acquires a positive charge. So this is about Daniell cell, you can see. So the electron flow is from anode to cathode, zinc to copper. Electron flow is from zinc to copper, and conventional current is opposite to the direction of the electron flow, and it is from copper to zinc. So here this is the cell notation. This one is the cell notation, and you are supposed to write cell representation, and in the cell representation you get the entire information regarding the cell. You see, zinc electrode is shown by S. So zinc to Zn2 plus, and this double line is the salt bridge, and on the right hand side you have Cu2 plus to Cu. That means on the left hand side it is clearly shown that zinc is dipped, Zn is dipped in Zn2 plus. and there is a salt bridge. This is your interface, and this is the salt bridge. And here what is happening, Cu2 plus is getting converted to Cu, getting deposited to Cu, and this is another interface. So it is evident that this side the electrode is zinc, and on the right hand side it is the copper. And since zinc forms Zn2 plus, it can be obtained by loss of electron, and so this is oxidation chamber. And Cu2 plus can gain electron and form Cu, so this is your reduction chamber. Both the chambers are interconnected by salt bridge, which is a U-shaped tube. Now here the net cell reaction is being shown, where this is your oxidation half cell reaction, and this one is your reduction half cell reaction, and this is your overall cell reaction, where you can cancel out the electron from the left hand side and the right hand side, and you add these two reactions. When you add them, then what happens is you get zinc plus Cu2 plus forming Zn2 plus Cu. And this is the cell representation. You can see this is anode, this is cathode, and in the salt bridge you have saturated KCl or KNO3. Yes, you can also keep K2SO4, and the electron flow takes place from zinc end to the copper end, and the conventional current is from copper end to the zinc end. Remember this lone in order to remember that left hand side oxidation takes place. It is the anode and attains the negative terminal. EMF of the Daniell cell is 1.1 volt, and this is the function of salt bridge. Salt bridge is U-shaped tube containing semi-solid paste of KCl or KNO3 or NH4Cl, which is inert electrolyte in gelatin or agar-agar jelly. The mobility of the ions, that is the cation and anion, are almost the same. That type of electrolyte you need to take. And why you have to take inert electrolyte? Such that it does not react chemically with the components, such that it does not interfere with the net cell reaction. So you have to take inert electrolyte. And what are the functions of the salt bridge? It actually externally completes the circuit, and it connects the oxidation half to the reduction half, the anode chamber to the cathode chamber. It maintains electrical neutrality. The continuous loss of electron from zinc actually results in the accumulation of the Zn2 plus ion near this. See what is happening? I need to show you the diagram again for this. When you see the diagram, here you can actually pause the video to write the notes, to see the diagram as well. So over here you see on the left hand side you have the zinc forming Zn2 plus. So with time there will be accumulation of Zn2 plus, and on the right hand side the Cu2 plus gets deposited as Cu. So there is accumulation of SO4 2 minus ion. Copper sulfate is there. If Cu2 plus gets accumulated as Cu, there is accumulation of sulfate ion near the cathode, and there is accumulation of zinc ion near the anode. So for that reason, the anion of the inert electrolyte, the anion of the inert electrolyte, they migrate towards the anode to remove the Zn2 plus near the anode. And the cation K plus, it migrates towards the cathode to remove the accumulation of the sulfate ion. Because if there is charge accumulation, the current flow will stop, the reaction will stop after some time. So I am moving back to the function of the salt bridge here. So you can see it maintains electrical neutrality. The continuous loss of electron from zinc rod, that is anode, results in the accumulation over the metal strip and can stop the reaction. Accumulation means accumulation of Zn2 plus. Zn2 plus. Near the metal strip actually means near the anode. Near the anode. And similar is the case in cathode, where you are seeing Cu2 plus gets discharged by accepting electron, and so there is accumulation of sulfate ion, negative ion. What ion? The SO4 2 minus ion gets accumulated, and the reaction will stop after some time. So to remove the sulfate ion, the positive part of the inert electrolyte migrates to the chamber, and to remove the zinc ion, the negative part of the inert electrolyte migrates to the chamber. The anions of the Solbridge migrate towards the anode compartment and prevents the accumulation of the charges, and the cation migrates towards the cathode chamber to prevent the accumulation of the charges, and thus it maintains electrical neutrality.